So, good evening, guys. So today our session is multi-agent orchestration with LangGraph. So don't worry, I just cover from simple basic into how do we production use these multi-agent orchestration framework. So let's move on to the topics. So here's the table of content. So we're starting from what is AI agent. Then we move into the agent environments and understanding. Then we move on why multi-agent systems needed and how the orchestration work when it comes to multi-agentic systems. Then the core orchestration design patterns and how agent communicate with each other, the communication methods basically. Then what are the frameworks that we can use to develop such a systems? And finally, with why we use LangGraph here with thank you. So first, I want to tell you a simple code here. So imagine you're building a complex e-commerce feature, right? So you need someone to handle user queries, maybe another to check inventory, someone to process payments, and another to send notifications. So each person is excellent at their job. So, but without a good coordination, customer get duplicate emails, inventory get double booked, and payment fails, right? So now imagine these people are AI agent working all day. So after this session, you will be understanding how this kind of a system work and how the agent will interact with each other towards for a specific goal. Okay, so before we move into the multi-agent systems, let's discuss about what is an AI agent. So basically, think like an AI agent as a specialized team member with with three core capabilities: perceives, thinks, and acts. Perceive means AI agent can observe the environment through its sensors and collect the data from the environment. Then it thinks and reasoning those data and then do act onto the environment. So this is basically in any AI agent three core capabilities. It may be a large language model based agent or a system design rule based agent, whatever the agent is, these three core capabilities are there. So then let's go to a like simple real world analogy here. Let's think about customer support agent in our company. So how the perceives work. The customer support agent can read customer emails or sees ticket queue. Then he thinks the issue category, which category those emails into, and checks the knowledge base how to respond for those questions or emails. Then it acts, responds to the customer. Maybe if the response is not possible for that customer agent, it will be escalated to the specialist and update tickets. These kind of things can be done. So this is basically how the AI agent works according to these three core capabilities. Next, from now onwards, I'm like the agents are LLM based agents. As I mentioned in previously, agents are way like we can implement agents even before the large language comes into the play into the industry, right? So agents can be dominated in the industry based on large language models or the rule based agentic system. In here, I'm discussing about large language model based agents. Simply, I explain about three core capabilities. In my thinking part, in LLM-based agent use large language model to do the reasoning process. That's the only difference between AI agents and LLM-based agents. As I mentioned here, this is LLM-based agents work similarly but use language models as their brain for reasoning and decision-making process. So when it comes to environment, so I told you guys the AI agent perceives and observe the data from the environment. So before we move into the multi-agent frameworks, we need to understand what is a AI agentic environment and how agent can understand the environment. So simply, the environment means everything the agent can interact with. It can be tools, APIs, databases, file systems, or it can be a other agents. The whole purpose of this presentation about introducing a multi-agent systems. So other agents also categorize under this environmental things, right? The next environment can be external systems, maybe Slack, GitHub, monitoring tools, anything. So another real world analogy here. So if you do a pull request, if you put a pull request on GitHub, you in the right pane of the GitHub, you might seeing a co-pilot agent. You can request your code review through a co-pilot agent. So co-pilot is also an agent which is powered by a large language model. So according to this code review agent, what is the environment that this agent can see? So it's basically the GitHub repository or the code files or the CI/CD pipelines. So how that agent can understand those GitHub repositories. It can read the pull request code bases. It can analyze the code changes. Based on that, it will act, comments on code, approves, reject, run test. That's basically how the environment and reasoning process and actions happen in an agent. So basically, I state in here first use input, then it sends the LLM processing. Finally, it decide which tool we need to call. This is not necessary step. We can skip for here directly if you want. Then the action execution happen. Finally, the response to the system or the user. So next, I want to discuss about why we need multi-agents. So normally you might think we have all the set of tools to interact with our system. Why can't we have a single agent doing all these tasks, right? So when it comes to AI agent, this also has limitations, right? So I list three of them in here, but there might be a huge list. What are the limitation of a single agents? Why we need to move to a multi-agent systems? So in here, complexity overload is a 1 point. So let's take a real world, right? So like asking for one developer to do the handle front end, back end, API testing, deployment, AI stuff, everything, right? It's not possible, right? So this is uh, a complex overload when it comes to single agents. Another one is context limit, right? Not like humans, large language models has token limits, can't process massive code bases, right? This is another reason why single agents may lack on these works. The final one is specialization. So one agent can't be expert at everything, right? This is also associated with context limit because we have to define the agent role, right? If the agent playing eh, so much pathways or specializations, it can be out with the context limit. So these are the main three reasons why we need to move to multi-agent system when it comes to some complex workflows. So let's talk about one specialized single agent, let's say DevOps agents. So which can have several tools like monitoring system health, deploy applications, handle security scanning, manage infrastructure, debug production issues. These are kind of a tools that specific DevOps agent can have. So next, I'll discuss about what is multi-agent orchestration simply means. So coordinating multiple specialized AI agent to solve a complex problem is basically called multi-agent orchestration. So I'll take a real world analogy here. Let's think about a Scrum team, right? Small Scrum team in your company. There's a product owner agent who defines the requirements and priorities, and then you have a Scrum Master agent who coordinates workflows and resolve blockers. And then we have developer agents who codes different components, front end, back end, API kind of things. Then after that, QA agent will evaluate and validate the functionality. Then finally, the DevOps agent handles deployments and monitoring process. So when it comes to this kind of a Scrum team, AI team, each agent may have different roles. Each agent may doing different things, but at the end of the day, they are working towards the same sprint goal. So that is the main concept of multi-agent orchestration. There's several agents working towards the same sprint goal, that but they may have doing a different task. Okay, so then let's talk about what are the co-orchestration design patterns available that we can build this kind of a multi-agent orchestration systems. But I want to tell you the reason why I'm stating a LangGraph perspective, because in the industry there's no the static way of defining this is exactly the orchestration design patterns you have to design the agents. This is highly depend on different frameworks. So these are the some of the architectures I mentioned here, which is stated in the LangGraph documentation that they told for their users. These are the architectures that they can build on top of the LangChain framework. The first one is a single agent architecture. This is a simple single agent. Let's take a write agent who has several tools like web scraping tools, spell checking tools, or any other tools, right? So simple agent have different tools to work on a specific task. So this is single agent architecture. So next one is a supervision architecture. This is also like a single agent architecture nodes here. Then there's a supervisor agent. The supervisor agent who is delegating the task into the worker agents. This is the simple uh, work behind the scenes of this architecture. So let's take a supervisor agent and then research agent, write agent, and spell check agents as a worker agents. Then let's take example, right? So let's say supervisor agent receive an specific topic to do a research. Then supervisor agent decide which worker agent should do this task. Then it decided to forward that topic to the research agent. So research agent have several tools, let's say web scraping tools, right? So research agent go through the internet and collect the data and return those data into supervisor agent. Then supervisor agent then take that results, then send back to the writer agent to write in a proper format of, of a research article, right? After research, writer agent responds to the supervisor agent, then supervisor agent then again forward that proper format of research article to the spell checker agent. So spell checker agent go through each line by line and validate whether there's a spell mistaking or whether all are validated or correct. After validating everything, the spell checker agent again send the final results into supervisor agent. Then supervisor agent finalize the system code. That's how it works. This is called supervision architecture in LangGraph. Then we have a hierarchical agent architecture. This is also consists of single node based single agents, LLM based agents, and the specialty of this architecture, the word itself, the architecture name itself define. There's a hierarchical reporting process. Let's say backend engineer and front-end engineer reporting to their superior program team supervisor, then team supervisor and other design team supervisor will reporting to supervisor agent. So this is basically the same architecture, but in a hierarchical manner. Next, we have network agent architecture. Uh, the next one also kind of a same kind of thing, a custom agent architecture. I will tell you what is the difference between those two architectures. In network agent architecture, each and every agent can communicate with all other agents. This is called network architecture, but in custom agent architecture, we have to define which agent can interact with other agent. That's the basic difference between this custom agent architecture and network based architecture. So these are the top 5 agent architectures that mentioned in the LangGraph documentation. But there might be different architecture like SOAM architecture or like any kind of a custom architecture, which is entirely different from these predefined architectures. I'm not going to explain about those architecture. These are the most common and famous agent architecture that you can build on top of LangGraph framework. So I'll explain about LangGraph framework. But before that, I told about like these network architectures, supervision architecture, then they are communicating with their superiors, they are reporting, they are returning response kind of thing. So how these agents communicate with each other? This is very important topic when it comes to multi-agent workflows, because multi-agent word itself means there's a multiple agents communicate with each other towards for a common goal, right? So agent communication is the exchange of information between autonomous agents so they can share knowledge, coordinate actions, and make joint decision in a multi-agent systems. Don't too much think about this. This is like simply message passing, right? You are passing your message, your idea to other agents. It can grab it, understand it, and return it. That's the basic idea of this communication. This is simple analogy. So there's a three main approaches. There's a several approaches of communication, but I'm stating here a very basic and commonly used agent communication methods. First one is shared memory approach. So this is basically means like a group chat. So if you are chatting in a WhatsApp group, let's say all the people in a WhatsApp group common, and we can give our ideas, we can message with each other. So this is basically the group chat, like using Slack channels. Everyone can see the message. So the pros is this is simple to implement and persistent history through the time. There's a cons here. This is why we are not going to shared memory approach when it comes to many agents, right? So this can be chaotic with many agents. Let's say there's a hundred of people in a WhatsApp group and they are chatting and chatting with each other. We cannot specifically grab what we need and what are the things we need to process, right? So that's the same thing happens in a shared memory approach. This can be get chaotic when with many agents. So next we have a message passing. This is basically like putting a message directly to someone's inbox, right? Like if let's say research agent and supervisor agent need to communicate with each other, they are communicating with each other with in a private channel. So no other one can see what they are communicating with each other. So this is like direct message, as I mentioned in Slack core email threads. Clear communication paths and better control is the pros in here. As a cons, this is more complex to implement when it comes to a framework wise or whatever. This routing path logic is bit hard or complex to implement. That's a con here. Then we have tool based communication. This is basically what we are using when it comes to MCP architecture. Exactly not the same, but this is the base of that. So agent communicate by modifying the shared tools and resources. So like updating the shared Jira tickets or Git repositories. Pros are natural integrations with existing systems, and cons, we require careful coordination to avoid the conflicts. Because the reason is there might be having a large number of tools, right? We need to decide which tool we have to call in the right time. So when it comes to a huge number of tools, we need to carefully coordinate those things. Otherwise, there might be having a conflict to choose the right tool here. Next, let's discuss about what are the other frameworks available in the industry that we can use to implement such a multi-agent AI systems. So we have first we have AutoGen, which is developed by the Microsoft. So they mentioned in their documentations about this is really good for the conversational agent, but they recommend this only for research focus, but not for production. Next, we have Crew AI, which is also another good framework which created on top of the LangChain. This is a very simple setup. You don't need a lot of knowledge. Like learning curve is really low because all the things are pre-implemented. You just need to mention what are the agents you need to create and what are the roles those agents will play. So this is great for small teams. Then we have LangGraph. So LangGraph is a complex workflow, like complex workflow implementer. So you can use your real world, like very low level coding components to create a LangGraph agent. That means Let's say basically you have an idea to implement some systems in a real world. You can exactly build that same system using LangGraph, because LangGraph gives you the capability to build an AI agent from the scratch. So it's provide the tool set. So it's basically really good for state management, complex workflows, and production ready. Then we have semantic kernel. This is also another product from Microsoft. This can be easily integrated with ecosystem of Microsoft, and also this is also a production ready, really good AI agent, multi-agent system framework. Then we have OpenAI Assistant API, and this is a very simple one because you'll be provided the interface. Then you can give the knowledge base, you can define the agent, then you can simply use it. So this is simple but limited. You cannot customization into your exact industry need or exact user need. Rather than this, there's many other frameworks available. Swarm framework is there, and there's a new frameworks coming into play. I just stated few of them to get an idea. And next, I want to discuss about from the beginning. I also mentioned we are using LangGraph in here. The reason I choose LangGraph because of four main reasons. The first one is a visual workflow design. When you define an agent, AI agent workflow in LangGraph, it gives you the capability to view how AI agent interact with other agent, how the communication process happen, how the tool process can happen, everything part by part you can view in LangGraph. So LangGraph gives you the capability to show this AI agent workflow as a diagram. This is a one cool feature I'm really love the LangGraph. Then we have integrating capabilities. So normally when it comes to production application or whatever the things, debugging and monitoring is essential, right? When it so LangGraph built on top of the LangChain ecosystem, there's a tool called LangSmith for monitoring and debugging. So using LangSmith, you can easily naturally integrate it with LangGraph framework. Then you can monitor each agent, how each agent interact, what are the agent token limits, how each agent call tools and interact with each other. Likewise, every single part you can monitor through this LangSmith. Then this framework is this is not like based on any depend on any LLM providers. So once you build a system, build a workflow using LangGraph, you can use OpenAI, Anthropic, even your local models, and simply just few changes of lines, you can use any vendor provider for LLM based models. So next we have a state management excellence. As I mentioned previously, this is really cool. Unlike other frameworks, LangGraph treat your multi-agent system like a state machine. If you know about the state machine is a mathematical concept that you can prove that system is working in an efficient way, right? So this LangGraph, the word itself means a graph based system. This can be easily modeled as a state machine and verify that system is working in excellent conditions. So next final thing is a production ready feature. So using LangGraph, you have the retry mechanisms. We have the checkpointing, save your resume workflows. Let's say one like middle of the workflow and one workflow is failed, right? So you can restore to a previous checkpoint which is already worked, then you can continue. And the next one is a human in the loop integration. This is a very important topic. I'm not going to deeply cover about the human in the loop, but this can be easily done using LangGraph. Then we have a memory persistence across the conversations and the streaming responses for better UXs. Then guys, that's basically about the today's session. So I want to share with you some Q&As here.